Hi to all. Today's topic is force on a charge moving in uniform magnetic field. If a charge moves in uniform magnetic field, then how the force will act on the object, that we are going to discuss. Look at here, this is a charge q, this is a charge q. It is moving with velocity v, right? Let us consider it is moving like this. This charge is moving like this. And now we are applying some magnetic field for this charge. For example, the magnetic field is like this there. This is the direction of the magnetic field. The magnetic field is applied along this direction. Okay? And the charge q is moving along this direction. This is the q charge. The q charge moves along this direction with velocity v, and magnetic field B is applied along this direction. The angle between the B and V is considered as theta. Then at that moment some force will act on the charge. Then force on charge formula. Force on charge in magnetic field. Force on charge in magnetic, force on a charge. Force on a charge. Okay, in magnetic field. In magnetic field. What is the formula for the force? On what factors the force depends? Right? Look at here. The force depends upon the charge, magnitude of the charge, and force depends upon the velocity. Okay? And force also depends upon the magnetic field, and the force depends upon the sine theta. Right? These are the factors on which the force depends. When we combine this, then we will get one formula, and we can write directly the formula, that is force depends upon all these factors. Then we write F is equal to QVB sine theta. Right? The force depends upon the charge, velocity, magnetic field and angle. Then the force on charge formula is QVB sine theta. This is the basic formula. Okay? And you have to remember, this is the force on the charge in magnetic field. And here this we can write in vector form. This is q into Vb sin theta, we write as V bar cross B bar. Right? This is in vector form. In vector form we write as F bar is equal to q into V bar cross B bar. Or the force on a charge we can also write as F is equal to QVB sin theta. What is q in this? What is V in this? What is V? Q is the magnitude of charge. Is it right? Q is the magnitude of charge. What is V? V is the velocity of charge. Velocity of charge. What is B? B is the magnetic induction. Magnetic induction. Okay? Theta is what? Angle between V bar and B bar. Okay? This is the formula for the force on a charge. Force on a charge formula is QVB sin theta. In vector form, F bar equal to Q into V bar cross B bar. Why we are writing like this? Because we know already A bar cross B bar formula is AB sin theta. Then by using that formula, AB sin theta is there, means A bar cross B bar we write. Here VB sin theta is there, we write V bar cross B bar. This is the force formula on a charge when it moves in the uniform magnetic field. Now, what is the direction of the force? Force value we can find out by using this formula. And how to find out the direction of the force? I want to know how to find out the direction of the force. Direction of force. Okay? How to find out the direction of the force? To find the direction of the force, let us draw one diagram. This is one plane. Okay? And now here some charge q is there. And here this is the velocity direction. And this is the magnetic field direction. Angle between them is theta. Then the force is perpendicular to the plane containing the V and B. This is the direction of the force. Okay? For example, if the force velocity is along x-axis, and the magnetic field is along y-axis, then the force will be along z-axis. Why? We know already the force formula is q into v bar cross b bar. Velocity along x-axis means v I cap we write. Magnetic field along y-axis means j cap we write. Q into vb I cap cross j cap we will get. But I cap cross j cap is what? K cap. That means the force is along k cap. Okay. Velocity we took along I cap means x-axis. Magnetic field along y-axis. But the force is along z-axis. Means force is perpendicular to the plane containing the velocity and magnetic field. The direction of the force is always perpendicular to the plane containing the v and b. Okay, we can write this sentence. The force is always perpendicular to the plane containing v bar and b bar. Okay, this is the direction of the force. Now let us discuss some cases, that is based on the different angles, then the force will be there. Now let us go for first, if the charge moves in the direction of the magnetic field, then what happens? Now let us discuss some cases on this. Let the first case, the case 1. Case 1 is that if charge moves in the direction of magnetic field, then how to write? The charge is moving in the direction of the magnetic field. That means we can write like this. This is a q charge, okay, and it is moving right side, right, with velocity v, and the magnetic field also right side. That means we write in this v bar parallel to b bar. Velocity and field are along same direction. Then theta is equal to what you will get? Right, theta is equal, we will get as 0. Theta is equal to 0 we will get. Then this we substitute, right? Then when we substitute this in the force equation, right, the force on charge formula is what? Force on charge in the magnetic field. This charge is moving in the magnetic field, and that force will act. The force formula is qvb sin theta, but theta is 0. Then we will get as sin 0 value is 0. Then this total term will become 0. No force. Okay, force does not act on a charge which is moving in the direction of the magnetic field. If any charge moves in the direction of the magnetic field, then force does not act on it, because sin 0 is 0. Since we know that the sin 0 is 0, that's why force does not act on the magnetic field. If the force does not act on the force does not act on the charge, then the charge will continue in the same direction. Its direction of the motion does not changes, right? And the charge continues along the same direction. Its path does not changes. Why? Because no force. If the force is there, there is a chance to change the path and velocity, but there is no change in the force. That's why here the charge continue along the same direction. Let us go for the next case. That is the case 2. The case 2 is that if charge moves opposite to the direction of the magnetic field, right? If charge moves opposite to the magnetic field, if charge moves opposite to the direction of magnetic field, That means field is right side. Let us consider the field is right side and the charge moves left side. This is a charge q, it is moving right side. The field up, or otherwise the field is applied to the right side but the charge is moving left side. Okay, look at here, there is some angle between the V and B. What is that angle? Right, the angle is 180. The charge is moving left side, charge velocity is left side but the magnetic field is applied right side, then the angle is 180 degree. Then here V bar is anti-parallel to B bar, right? In this case the theta is how much? 180 degree. Okay, then what about the force on charge? In this case also the force on charge become 0, right? F is equal to QVB sin theta. Theta is 180. Sin 180 is again 0. Then again the force you will get is 0. No force. That means if a charge moves either in the direction of the magnetic field or opposite direction of the magnetic field, at that moment there is no force on the charge. Now let us go for the one more case, that if charge enters perpendicular to the magnetic field, then what happens? Okay, let us see. The first case, second case is completed. The first case angle is 0, second case angle is 180, and the third case I am going to explain, that is angle is 90 degree. Right? Then what happens? This is very important case. There is a case 3. I am going to explain the case 3. What is this case 3? The case 3 is that if charge enters perpendicular to the magnetic field, right? Right, look at here how the diagram will be there for this. Now the charge enters perpendicular to the magnetic field. This is the magnetic field. Let us consider. This is the magnetic field. The field is inward. The field is inward. Look at here, this is the field and the field is inward. And the charge q, let us consider one charge q entered with some velocity v, that velocity for example along x-axis, okay, velocity along positive x-axis. Then what happens, in which path it will goes, and then what is the direction of the force, that I want to know. Here the field is inward, okay, field is inward. Cross means inward field, the field is inward. Look at here, the 3 axes if you take, right, let us consider, and this is right side x-axis, okay, this is right side x-axis, upward y-axis, towards u, this is z-axis, right, 3 axes mutually perpendicular to each other. These two are perpendicular and this also, these two are perpendicular and these two are perpendicular. Now look at here, what is the direction of the force and how much force will act if charge enters perpendicular to the magnetic field? Velocity perpendicular to field, then we write theta is 90 degree. Then what about the force on charge? Yes, it was very simple. Force on charge formula already we know. Is it right? What is the formula for the force on charge? Formula is QVB sin theta. Right, that you know already. Then in this you substitute theta is 90 degree. Then sin 90 is 1, then the force will become QVB, right? And this is the maximum value. This is the maximum value. Why it is maximum? Because sin theta maximum value is 1. That's why the maximum force acts on the charge. Sin theta maximum value is 1. When you write sin theta maximum, then the force also maximum. The maximum force formula is QVB. Maximum force formula is QVB. Let us see the direction of the force I want to know, right? Look at here. You see the velocity is force formula in vector form. If you want to know the direction, v bar cross b bar is there. That velocity is along x-axis. We write v I cap. Okay. Magnetic field is along z-axis and inward. Z-axis and inward. This we write as negative x. Then the q v bar cross I cap cross k cap. We will get the j cap, right? J cap. We will get k cap cross I cap is j cap. You know already. That means the force on this charge will be along. Force on this charge will be along y-axis, right? Along y-axis. Look at here. The force will be along this direction. The force will be along this direction. This is the direction of the force. Force will act along this direction. This is the direction of the force, right? This is the direction of the force. Then, when the force acts along this direction, this force, in this case, it serves as centripetal force. How it acts? It acts as centripetal force. Due to this charge will move in circular path. This charge will goes in circular path. Why the charge goes in circular path? Because when the charge enters perpendicular to the magnetic field, that force will act. But that force acts as centripetal force. That force is toward the center. That's why it acts as centripetal force. For example, if charge comes to this point, okay, if charge comes to this point, like this velocity will be there. Here the force is again this side, it will be there. Okay, if charge comes to this point, like this, then the force direction is towards center. It will be like this there. That means at every point the force will act like centripetal force. This is the direction of the velocity. Charge is moving like this, and the force direction is towards center. That means the charge moves in circular path. Charge moves in circular path. This force acts as centripetal force. Centripetal force. Due to this, charge moves in circular path. Circular path. Right? Now, that means whatever that force is acting, magnetic force will act as centripetal force. Here the magnetic force act as centripetal force. Centripetal force. What is magnetic force? Formula is mv square by r. Sorry, magnetic force already we find out it here. QVB sin theta by theta 90. Then we got as QVB. Centripetal force formula we know already in circular path. If m mass of charge is moving, then we write the centripetal force formula is mv square by r. From this we can find out the radius of the circle, right? Radius of circle we can find out, and momentum of the charge we can find out, kinetic energy of charge we can find out. That all things we are going to find out now. Okay, let us see how they will be. First I am going to find out the radius. By using that equation we can easily find out the radius. Look at this equation. QVB, magnetic force is the QVB. That is equal to centripetal force. The centripetal force formula is already you know. That is mv square by r. That any charge, any object, any particle, if it will move in circular path, then centripetal force is required. The centripetal force, this magnetic force serves as centripetal force. That's why the charge will move in circular path. Now let us see. We can simplify this. Here v and square will cancel. Then the remaining step we will get as q into b is equal to mv square by r we will get. One v will cancel it here. mv by r we will get. Then from this r we will get as mv by qb. right? The radius of the circle, we will get as r is equal to mv by qb. Okay, this is the formula for the radius. And now in this, what is mv? M is the mass of charge which is moving in circular path. V is what? Velocity of charge. Velocity of charge. What is B? Magnetic induction, you know already. What is Q? Q is the charge. Very simple, this is the terms. If you want to know radius formula in terms of kinetic energy of charge I want to give, then for that we know that radius is equal, r is equal to mv by qb. This we write as p by qb, because mv, mass into velocity, is the momentum, but momentum formula we know from the basics, right? Okay, what is that? Kinetic energy is equal to p square by 2m. From this p formula we write under root 2m ke. Is it right? P formula we write as under root 2m ke. Then we write as r is equal to p by q, but p is what? Under root 2m ke we write. 2m ke by q, right? By qb. What I did here? mv I wrote as p, p formula I wrote as under root 2m ke. What is ke here? Kinetic energy of charged particle. And the next, I am going to derive the momentum of formula. Momentum of charge, what you will get? Momentum of charge formula. Momentum of charge. Momentum of charge formula is, we know already radius formula, we derived it here. mv by qb. This is p by qb, right? Then the momentum formula is qbr we write. Momentum formula from that is qbr we write. Next I am going to derive one more formula, that is kinetic energy of charged particles. Okay, I am going to rub this. Kinetic energy formula in terms of momentum, we know the relation between the kinetic energy and momentum. K is equal to p square by 2m. From that we write the kinetic energy formula. The kinetic energy of charge. Okay, the kinetic energy we write as K is equal to half mv square, or otherwise p square by 2m we know. P square by 2m. P is what here? qbr. How we got this p? Right, look at here. Radius is mv by qb from this, and from that mv we write as p by qb. This qb taken to left side, p is equal to qbr. qbr whole square by 2m we write. Okay, this is the kinetic energy formula. And the next I am going to derive one more formula. Circular path, the charged particle is moving in the circular path. Then what is its angular velocity? What is the time period? That I am going to derive. Okay, then for that, angular velocity of charged particle I want. Angular velocity of charge. The charge is moving in circular path, it has some angular velocity. Then we know already that we know from equations, I will write this as equation 1, and this as equation 2, this as equation 3. Various formulas we are deriving. These all formulas are useful to solve the problems. Then how to, from equation 1 we can write one thing. What do we write from equation 1? We write as r is equal to mv by qb. R is equal to mv by qb. Here we write, but we know relation between the linear velocity and angular velocity. V is equal to r omega. This we substitute in above equation, m into r omega by qb we write. This r will cancel. Then qb is equal to m omega, and omega is equal to, we will get as qb by m we will get. The charged particle angular velocity is this one. This is the angular velocity. And the next I want one more formula, that is time period. The charged particle is moving in circular path, then how much time takes to complete one rotation, right? The time period formula I am going to derive. How we can derive the time period formula? Time period is 2 pi by omega, that we know already. The formula for the time period means what? Time to complete one rotation, right? This is the time to complete one rotation or revolution. Okay, one rotation or revolution. For one revolution or for one rotation, how much time takes? That is the time period. Then the time period formula we know already, 2 pi by omega. But what is omega here? We got QB, 2 pi by omega is QB by m. Then time period formula we will get is 2 pi m by QB. This is the time period formula. Then what is the frequency of charge? Frequency means number of rotations per second. Okay, number of rotations per second. In lower class we know the frequency is the reciprocal of time period, right? Nu is equal to 1 by t. We write the reciprocal for this, QB by 2 pi m. This is the frequency formula. The frequency formula is QB by 2 pi m. Okay, this is the various formulas. These formulas are useful to solve the problems, and these formulas all are linked one with another. This is the fourth, and this is the equation 5, and this is 6, and this is 7. Okay, and take the screenshot and note every point. Now first we discussed the one case that charge moves in the direction of the magnetic field, angle 0. Charge moves opposite direction of the magnetic field, angle 180. Charge moves perpendicular to the magnetic field, theta 90. Then if charge moves other than these angles, then what happens? Let us see. Other than 0, 180 and 90, then what happens? I am going to rub these all things and then I will explain. Okay. Okay, look at here, one more case I am going to explain. This is the last case. If charge Q moves in the magnetic field B with velocity V at an angle theta, right? The charge moves at an angle theta. The theta is not 0, not 180, not 190. At that moment, look at here, this is the charge Q. It is, this is x-axis, this is for example y-axis, this is z-axis. Look at here, the charge Q is moving with velocity V at an angle theta with the magnetic field. The magnetic field is along x-axis. Okay, and now this velocity is resolved into components. One component will comes along the x-axis, that is v cos theta, and one component will comes along y-axis, that is v sin theta. Okay, and what the v cos theta will do and what the v sin theta will do? V cos theta is in the direction of the magnetic field and v sin theta is perpendicular to the magnetic field. Okay, v sin theta is the perpendicular to the magnetic field. Then now look at here, this is the v cos theta is a component of velocity in the direction of the magnetic field. Okay, v cos theta is the component of velocity in the direction of the magnetic field. Component of velocity in the direction of magnetic field. Magnetic field we are taking along x-axis in the direction of magnetic field. Okay, due to this charge moves along x-axis along the direction of B. Okay, v cos theta is the velocity, is there part of velocity along the direction of x-axis. That's why the charge also moves along the direction of x-axis. And v sin theta is the perpendicular to the magnetic field. Due to v sin theta, right, what the charge will do? The charge moves in circular path. That means simultaneously the charge moves. V sin theta is what? V sin theta is the component of velocity. Component of velocity perpendicular to the magnetic field. Perpendicular to the magnetic field. It makes charge to move in circular path. In circular path. Due to v sin theta, charge moves in circular path. Due to v cos theta, charge moves along x-axis. Then simultaneously the two are there. That's why the charge moves along the circular path, and along with that it also goes in forward. Okay. Due to v sin theta, v sin theta is perpendicular to the field. Due to that it will goes in circular path. Okay, like this it will move. Then what happening here? The charge is moving in circular path, and the charge is also moving along x-axis. Then the path of the charge will become helical path. The path of charge or the charge moves in helical path. You can write like this. Charge moves. In this case, how the charge moves? Charge moves in helical path. Helical path. Why helical path? Charge rotates and also moves forward. Why charge will rotate? Because actually if velocity perpendicular to the field, then the charge will move in circular path. We know already that is case, one case we discussed, that is case 3. If case 1 we know the charge moves if it along the direction of the field, then the charge will continue in the direction of the field. That means here v cos theta is in the direction of the field. That's why the charge will move in the direction of the field, right? V cos theta charge will continue in the direction of magnetic field. Okay, due to v cos theta charge goes right side. Due to v sin theta is perpendicular to the field. That's why it will move in circular path. The combination of circular path and linear motion, it will become spiral, just like a spring. Okay, with the rotation it will goes forward. With the rotation it will goes forward like this. Okay, this is the path. And then now let us see, in this case I want the radius of the circle. What is the radius of the circle? Radius of circle. Radius formula is mv by qb. But here we have to take the perpendicular component. Due to perpendicular component only, charge moves in circular path. That's well. Here what is the perpendicular component? V sin theta is perpendicular to B. Is it right? In this, V sin theta perpendicular to B and V cos theta parallel to B. Is it right? In the figure. And now we write perpendicular component. Due to perpendicular component, that will move in circular path. That's why we write here radius formula is mv sin theta by qb. If you want to write the time period formula, okay, time period, angular velocity formula we write, okay, time period we write, time period formula we write. What is the time period here? Okay, time period, again we write the time period for one formula is 2 pi by omega, another formula time period for one rotation, distance by speed we write, distance is 2 pi r, speed is v, we know already. Right here we perpendicular, we have to write 2 pi r we write as mv sin theta by qb by v perpendicular is v sin theta. Here this will cancel. Then again we will get the time period as 2 pi m by qb. In this case also the time period formula is again 2 pi m by QB. The same formulas are applied. Only the radius formula is changed. Radius formula is changed. Okay. The time period formula is again the same. The time period is independent of the angle. Okay. 2 pi m by QB. And now let us see one more case, that is in this pitch of helix I want to find out. What is pitch of helix? Look at here. For every rotation the charge is moving somewhat forward distance, right? That is called as pitch of helix, this distance. In one rotation the charge travels somewhat forward, okay, right? Due to the v cos theta it is moving forward, due to v sin theta it is moving in circular path. And now in one rotation how much forward distance the charge can travel, right? For every rotation it is rotating and going forward, rotating and going forward, okay. And v sin theta is the component of velocity, it is perpendicular to the field, it makes the charge to move in circular path, and v cos theta is the component of the velocity, it is in the direction of the magnetic field. Due to that the charge moves along x-axis, right? The what is pitch of helix? Now I am going to rub this and then I will define the pitch of helix. This is important. What is pitch of helix? Pitch of helix is the linear distance travelled by the charge in one rotation. In one rotation how much distance the charge is moving, that is called as pitch of helix. Look at here, the next side heading is pitch of helix. Helix. The charge is moving in helical path. Then what is pitch of helix? Pitch of helix is the horizontal distance or the linear distance travelled by the charge in one rotation is called as pitch of helix. For every rotation it is going forward, right? Not only rotating, right? Pitch of helix. Then pitch is nothing but distance only. Pitch is nothing but pitch of helix is. Okay, we are discussing the pitch of helix. What is pitch of helix? Pitch of helix is the horizontal distance travelled or the distance travelled by the charge in one rotation. Okay, look at here. In our topic we are discussing that the charge is rotating and moving forward, right? Charge is rotating and moving forward like this. It is rotating and along with that it is moving forward. In each rotation little bit it is going forward. Then in one rotation, before one rotation here the charge is there. After one rotation it goes to somewhere. That means it is travelling some distance along the horizontal. This side velocity is v cos theta in the diagram you see along the x-axis. Along this direction magnetic field is B. Distance travelled I want to know. Then the pitch of helix is nothing but the distance travelled, okay, in one rotation. Then pitch of helix is nothing but a distance. This distance is equal to speed into time we have to write. What we have to write? Speed into time we have to write. Then what is the speed? What is the speed along the x-axis, along the direction of the magnetic field? That is v cos theta. And in one rotation how much distance travelled they are asking. In one rotation the time period is we have to take t. Actually the object is the charge is moving along the x-axis because of component of velocity v cos theta only. That's why we have to take the speed is only v cos theta. Then in one rotation distance travelled we have to find out. That's why time we have to take as time period, okay. Then but we know already time period formula v cos theta into time period formula is what already we know. Time period in one rotation we derived it here, okay, t equal to 2 pi m by qb, right? Then we have to substitute it here. Then finally we will get the pitch of helix formula, okay. This is the pitch of helix formula v cos theta into 2 pi m by qb, okay. This is the formula for pitch of helix, okay. This is today's topic and write notes on it, okay, by taking screenshots. Thank you for watching my lectures. Subscribe my channel, share to your friends. If you have any doubt, you can WhatsApp me, right? And my WhatsApp number is 9963817138. Okay, thank you.